All right, let's talk about a term you've probably seen popping up everywhere: context engineering. This is a huge deal. It's a major shift in how we're building with AI, and it goes way, way beyond just making simple chatbots. We've all had those conversations with chatbots, right? Asking for a quick recipe or a summary of an article. But the real frontier, the next big thing, is getting AI to actually perform complex, multi-step jobs all by itself. So how do we get an AI to not just talk about a problem, but to actually roll up its sleeves and solve it? Well, that's where things get really interesting. To get there, we have to understand that the way we've been talking to AI, it has to evolve. We've got to move beyond just simple one-off prompts and into a much more powerful, more structured way of giving instructions. So let's break this down. On one side, you have standard prompting. Think of it like a normal conversation. You ask for running shoe advice, the AI gives you some ideas, you ask a follow-up. It's a back and forth where you're steering the ship. But on the other side, with context engineering, you're building an AI agent. You're not having a chat. You're handing it a complete, detailed instruction manual from the very beginning. The goal is to build something that can handle customer refunds, book your appointments, or do deep research all on its own. Okay, so this instruction manual we're talking about, what is it really? Well, that, my friends, is the heart of context engineering. It's all about perfectly packing the AI's context window. You can think of that as its short-term memory, with every single thing it needs to get the job done right on the very first try. The idea is to eliminate the back and forth and just get to flawless execution. I absolutely love this analogy from Andre Kaparthy because it just nails the shift in mindset. He says the language model itself, the AI brain, that's the CPU, the raw processing power. But the context you feed it, that's the RAM. You're not just talking to it anymore. You are literally loading a program into its active memory. And that's the bottom line, right? We are moving from having a casual conversation to a process of deliberate construction. We're using structured, natural language as our new kind of code to build really sophisticated applications that can go out and act in the world for us. So if we're programming with words, what exactly is the application we're building? Well, the end product, the thing we create with all this, is called an AI agent. And to really get what an agent is, I want you to think about a burger. Seriously, stay with me here. A burger isn't just one thing, is it? It's made of a bunch of essential layers, and every single one has a very specific job. Let's build our agent burger. The patty, the absolute core of the whole thing, that's your model. Think GPT, Claude, or Gemini. Then you need condiments, right? Those are the tools that give it flavor and capability, like access to your calendar or a web search. The fresh stuff, the lettuce and tomato, that's its knowledge and memory, a database it can pull facts from. Then you've got to have audio and speech so it can interact with us. Now, what holds it all together? The bun, those are the guardrails, the safety rules. And finally, the whole thing sits on a plate. That's your orchestration layer, the systems that actually deploy and manage the agent. So you've got all these amazing ingredients ready to go. What's your job in all this? You're the chef. You're the one who writes the recipe, that super detailed master prompt that tells the agent precisely how to put all those pieces together to achieve a specific goal. Okay, enough with the analogies. What does one of these recipes actually look like in the real world? Let's get our hands dirty and break down a real system prompt for an AI research assistant. First things first, and this is absolutely critical. You give the agent a role. You're basically giving it a job title. This is so important because it's no longer just a generic AI. Now, it's a specialist with a crystal clear mission. Then comes the task. And look, this is not a vague suggestion. This is a precise, step-by-step algorithm. We're telling it exactly what to do. Notice how specific it is. Extract up to 10 subtasks, prioritize them, generate a JSON output. Every single step is clearly defined. Next up, you have to be an absolute stickler about the output format. Here, we're demanding it gives us the answer in a clean JSON format. Now, why does that matter so much? Because a clean, predictable output means another computer program can instantly grab that data and use it without a hitch. It's what makes the whole automated system work together seamlessly. And last but not least, you lay down the law. These are the constraints and capabilities. You're telling it what it absolutely can't do, like no opinions, stick to the facts, and what it can do, like using its web search tool. This is basically putting up the essential guardrails to keep it laser-focused and prevent it from going off the rails. Okay, so what we just looked at,
That's the foundation. It's powerful stuff. But when you want to build really serious professional-grade agents, you have to get even smarter about how you manage all this information.
The pros use all sorts of clever strategies. Things like giving the agent a scratch pad to write down its thoughts, or letting it pull in data from a database only when it needs it, or even finding ways to kind of compress information to fit more into its memory. It's all about managing that flow of information, and it's what lets you build these incredibly complex systems where you might have multiple AI agents all working together.
So let's just zoom out for a second. What does all of this really mean? We are witnessing a fundamental change in how we tell computers what to do. We're moving away from writing rigid, unforgiving lines of code to, well, to designing complex behaviors using natural language. So the really big question I want to leave you with is this. If programming is starting to feel more like a conversation, what does that mean for the future of programmers? It's definitely something to think about.